Thank you, Shauna. And now to dive into the concept of scaling out with the Oracle Cloud, we are here with Mahesh Thiagarajan, Executive Vice President of Oracle Cloud Infrastructure. How are you, Mahesh?
I'm doing great.
Good. It's
I'm
great
excited.
to have you here. Yeah, we're super excited to have you here. It was a great keynote by Clay, and we're talking a lot about this idea of scalability, right? Scaling out, scaling up, scaling down, and we are here to talk with you about scaling up with superclusters. Are you in for that?
I'm excited.
Okay.
We're also going to talk about security in a minute, but I wanted to interrupt because last year you and I had a little chat about security.
That's right.
Right? And now it's the topic.
It is.
It is.
Yeah.
I think I was just seeding you with a bunch of ideas, and Larry talked about it this year.
That's right.
Yeah.
That's right. So, you're ahead of your time, is what I'm trying to say.
Exactly. Well, okay, let's get back to superclusters. And I kind of just wanted to start from a super high level, get it? I was so proud of myself
really
I know.
when I wrote that question.
Having to pretend to laugh at those.
I know. I did that just now.
Oh yeah, I'm used to it, don't worry. What is a supercluster?
Look, I think when you think about the innovation that's happening in AI, right, be it at the hardware level or the data center level, what Oracle's trying to do is to bring all of that technology so the AI innovation happens at a much rapid pace. Well, how do you do something at a much rapid pace? Well, what's something that takes, like let's say for example, a training job that takes 1,000 GPUs and it takes about 3 months to do the work.
Right.
What can we do to make that faster? And what Oracle is doing is bringing this concept of superclusters to the next level. And what we're announcing today is this notion of 130,000 plus superclusters. So these jobs that take so long to do, right? Because when you're training a job, it takes months to complete.
Right.
With the power of a supercluster, which is thousands of GPU, hundreds of thousands of GPUs interconnected to reduce the time it takes to train and really realize value for our customers. So supercluster is hundreds of thousands of GPUs put together, clustered, maximum performance, so at the end of the day, customers can realize value faster.
Love that.
I want to understand because so Kendall and I went to the Salt Lake City data center. We were in that supercluster, right?
Yeah.
And one of the things we were talking to Clay about is, he would say, well, we've been building clusters for a long time, right? Exadata.
That's right.
So to build a supercluster, though, is kind of lots of clusters together. But you say that and it sounds like, well, we just connect them like Legos. How hard does it get when you go from, what did we see, 23,000 when we were there? Maybe it was even more than that, to now you're talking about
131,072 GPUs.
Yeah. So what is it linear or exponential, the complexity, or does it go down?
No, there is a lot of complexity when it comes to actually powering these things together. And you saw that in Salt Lake City, that's only about 23,000.
Yeah.
Right? So only 23,000, and that's a day of the past. The hard engineering challenges first comes from the networking dimension, right? When you think about 131,000 working together in unison, even if 1 or 2 GPUs are slow, the whole job slows down. So when you think about operating these these GPUs together, your network has to be extremely performant. So to give you an idea, we're going to have up to 104 petabits per second of network throughput for these GPUs to talk to each other and actually operate at an extreme performance so customers can realize every single ounce of capability that exists on these GPUs, right? And so that's really hard. The second challenge comes from cooling them.
Right.
Right, now you have these GPUs that are running so hot. I mean, there's so much noise in Salt Lake City, right?
Yeah.
You got to cool them. So, NVIDIA and us are partnering together on, the liquid cooling technologies that allows us to cool these GPUs so they can actually run at peak performance. That's the second challenge. The third, predominantly comes from managing them, repairing them at scale, right? So, I joke this with some customers. when humans walk around GPU clusters, performance drops. So when you walk near it, Kendall, I was very worried about my performance.
Clicking and clacking in my high heels.
But the good news is you walked around clusters that were not live.
There you go.
But we actually manage this like they're extremely finicky objects, because every single bit of performance matters, and so there's a lot of challenges that comes with building these clusters.
For sure. The next time I visit, when we have liquid cooling, can we put color in there so it's like blue,
please,
red?
Red.
No. That is literally how performance drops.
Exactly.
I'm not even going to let you near the cluster. What are you talking about?
Exactly.
You get no color.
I used to build my own computers, and you could add the colors to the. No, not the same thing.
Please, never. Don't do that. Don't
do that.
All right. Don't let me anywhere near the data center.
We're not going. Just stay here.
Yeah, you're good here.
But so why the need now? Why? What are some of the customer challenges that we're concerned about that we would, superclusters at all, let alone 131,000?
Look, I think if you think about the innovation that is happening in the AI or model or LLM industry, right?
Yeah.
There's tons of new innovation that's happening for those models, one. Two, I think from a training perspective, the industry is moving on to pictures, videos, things that are extremely large scale, gone from text now to all these advanced things, and obviously we're also going into the code assist and developer portfolio as well. So things are getting more powerful. More innovation on the models means more power from the hardware, more data centers, more network, more storage, and then it all has to come together, because it only takes one GPU to be bad for this whole 130,000 cluster to not do well.
Right.
So.
And then you got agents now.
Oh yes, so look, I'm talking about the infrastructure. Oh man, look, I'm the engine guy. I build the engines for the cars.
Yeah.
But people talk about the cool things on it. So I'll tell you, what this does is it allows these models to be trained, and these large training customers love that.
Yeah.
But then these LLMs now power our generative AI services, right? And enterprise customers now get these generative AI services so they can integrate them into their apps. Then you go one level up. All of the announcements with intelligent agents and everything that Steve Miranda announced today morning, that now is powered by the work that we're doing underneath.
Right.
Now your Fusion apps get better. Your NetSuite apps get better. Your emergency response applications in the industry vertical apps get better. Risk management in, our risk solutions from industry vertical apps and project management, all of that gets better. So when a customer, if you're at the infrastructure level innovating on LLM, you get tremendous benefit. You're an enterprise looking to leverage the elements, customize it, you have products. And you see value, so you can realize that value. You go all the way up to our industry apps and our Fusion apps.
Right.
There's value across the board.
Yeah,
right?
Absolutely.
Let me ask one more question about the building of these superclusters. And you talked about the networking and the cooling. If we jump over to a little bit more on the networking side, sort of the secret sauce behind the superclusters, can you talk about how it's architected that way?
Oh, for sure. As we've been pioneers in the RDMA technology for a very long time, because that's something that Exadata actually has had for a long time. So we're actually one of the early pioneers or technology companies that bet on the RDMA technology. We've brought that into our database to turbocharge it to be what Exadata is today, powering the world. We took the benefits of doing RDMA, we brought that on to our high performance computing environment, and I think we did that 6 years ago. And now you fast forward down to what we're doing with these GPUs and these AI training models. We've been doing this for a long time. And so for our ability to keep scaling this up, bringing the best, giving the best performance, a lot of hard work, but something that we've been doing for decades. So it was not new. For us, it was just carry on the advantage and make sure customers realize that value of the hardware, and you can't do that without the networking.
Yep.
You kind of already hit on this, but we have time, so I want to dive in a little bit deeper. What advantages do superclusters offer over traditional deployment architectures or customer workloads?
Yeah, I think it fundamentally comes down to that performance of them working in unison, right? So think of this as, you take a piece of work and you say, look, we have to complete this task, and you give it to 100 GPUs. They all go and say, I'm done with my part. Let's all come together and say, we're done with our work. let's pick the next job. But imagine, if these things are not performant and the last GPU is still doing its work, the others are waiting.
Right.
Like, all right, I'm using the power. If they don't come back in unison, that actually becomes a problem. And that's where, a lot of the innovation that we're doing is to actually eke every bit of power and, use them effectively.
Yeah, so what is Oracle's differentiator in this space, in comparison to other cloud providers?
It's on multiple dimensions. One is the scale of it. Second is definitely our networking technology, our ability to offer that peak performance, right? Third is, it's not just the compute and the network, the storage has to go hand in hand, right? All of these computers are hitting a storage server to get the next bit of work. They're getting the latest bit of data.
Right.
And then once they're done with the data, they need to write it back. And imagine 131,000 GPUs doing all of this work and going and putting that back. So we are offering advanced storage capabilities. Fourth is that when you have such a large thing operating, the ability to maintain and manage them is hard, right? You need to be able to observe the power utilization. You need to observe how the GPU is performing. You need to observe the storage performance. You need to make sure how the clients are behaving. You need to make sure the workers are picking up the work at the right time. So there's a tons of observability work that we're doing. So if you really think about our differentiators, it's predominantly on the network. It's on our ability to offer high performance storage, cluster scale, and lastly, it's also our ability to execute, right? When you think about, a customer coming in and saying, hey, I need to train my model, I got about 4 months, I need to realize this value, Oracle has the ability to deliver 10,000 GPUs every 10 days from the time power is available, right? So, and that requires tremendous amount of optimization. We use our own softwares for project management that are industry vertical apps and Fusion, and we use that for preparing our project schedules.
Sure.
But we also execute, which is a secret sauce, which is invisible, easy to say, but to light up 10,000 GPUs and walk away from the data center in 10 days, is something that we do as well.
Yeah, and then when you get to 131,720?
131,072.
72.
Whoa.
Okay, that's close. I added a zero. All right, let's talk about security, but actually let's broaden it out, because I think sometimes this notion of sovereignty gets commingled with security.
Right.
Data residency, privacy. These are each different.
They are separate pillars. Yeah.
But let's start with security, and specifically sticking with superclusters for a moment. What security features are embedded into OCI to protect sensitive data and applications?
Look, I think we've had a built-in security model, security-first approach. Larry talks about it every single time. There's nothing that goes out of OCI that doesn't actually have thorough security reviews and deep testing from a security perspective. But it goes back to the bread and butter and how we started. We started out with building bare metal computers, right? And we're the only cloud today that offers bare metal GPUs, right? What that does is it enables customers to get the data, operate on them from a security perspective, also at the highest performance. So our bare metal computers benefit our AI customers. Then you step back to everything that OCI does, from our physical security, all of the products, authentication, authorization, all of the advantages around CloudGuard, they're all inbuilt into OCI. As a customer, you don't have to do, if you're an AI customer, it doesn't matter, you get all of those features for free, it's inbuilt. Another cool thing that we do, one of the things that customers do when they buy these large clusters, right, 3,000, 10,000, they got their research team in a corner. They got their production data, they got their research team. They're not building separate clusters. They're building a giant cluster because they want the flexibility to take those GPUs if they want to finish a job faster and say, researchers, wait for a week. We want this job to run. What Oracle does is that we have the ability to isolate clusters that are connected together. So you can say, hey, I have a 3,000 GPU cluster, but for a week, I want 256 GPUs together in unison, and I want the rest in a different environment. I want the security of that to be different from this. Those are sort of inbuilt capabilities. We don't talk about it a lot, but it's sort of inbuilt into our RDMA network philosophy in terms of isolation and primitives and security. So that's something we do. So everything that we do on Oracle and OCI is available for AI. There's a couple of special secret sauces we got as well.
Yeah, what else are we doing to support customers who have specific sovereignty requirements or other super complex regulations that they have to comply with?
Look, I think it starts with our fundamental strategy around our deployment choices, right?
Yeah,
like
right.
we tell people we have customers who operate on our public cloud, or government cloud, or sovereign cloud, or isolated regions, or dedicated regions, or Alloy. These are essentially various deployment choices. So as a customer, they can get Oracle technology wherever they are.
Right.
So when it comes to sovereignty, our philosophy is we know data is distributed. It's in multi-cloud, it's in Oracle Cloud, it's on-premises on our Exadata, it could be in another place. We believe that AI should sit where data sits.
Yeah.
Right? So with all of our deployment choices, what we do is we bring all of that, and we bring our AI infrastructure and AI clustering technology to our sovereign customers as well, right? So 2 examples of customers who are very excited, and they are super excited to bring this innovation is NRI. NRI is actually building out, we're building out AI clusters for NRI in their DRCC and Alloy regions.
Wow.
And Etisalat is another big customer of ours, we're building out GPU clusters for them in their dedicated region. And with NRI, they're interested in building a custom LLM model for themselves. With Etisalat, they're interested in using our generative AI services, integrating with their enterprise apps. So everything that we talked about value is not just in our public cloud. It is for all of our customers, all of our deployment choice customers, they get AI too.
Wow.
Yeah, I was just talking just a few minutes ago with Palantir and about their choice of OCI, kind of the same thing. Common set of functionality,
right.
No matter the deployment model.
That's right.
So you can count on that, whether you're an Alloy or you're running in a public cloud that has, 20,000, a supercluster of 20,000
right.
GPUs. So let's talk about some of these examples and how it's allowing them to serve their customer base. I mean, NRI is a good one, right? Our customer's customer is the financial institutions of Japan.
That's correct.
Right? And so they're building an AI platform of SaaS applications.
That's correct.
For their customers, right?
That is correct. It's literally, it goes back down to when you think about the models, what NRI is trying to do, right? NRI is a leading application provider and an integrator and an infrastructure player in the Japanese market. And what they're trying, and their stock exchange is running on top of NRI. Right. So being able to serve a wide variety of enterprise apps, financial vertical apps, and bringing AI to them, it's pretty cool, right? And Oracle is an innovator and a partner that allows NRI to thrive in the Japanese market. And something that Safra says, we like to be in the shadow, right? We want our customers to win.
Exactly.
So we're always in the shadow. So we know that a significant chunk of our Fortune 100, Fortune 1000 companies run on Oracle technology, just like, and we bring the technology to them, and we want to be in the shadow, and we want their customers and them to be successful, and that's what we do with Alloy.
I think we overused the term ecosystem, but that ability to allow that ecosystem to expand behind the scenes using our technology. I do want to touch on something Larry talked about on stage, which is kind of the next wave of cloud security.
That's right.
And he talked specifically about Zipper, Zero Trust packet routing. Mm-hmm. And we didn't talk about that last year, you and I. I don't think we did, but I don't think we talked about it. We didn't name it.
We didn't name it.
Right.
What we did is we announced that concept. Right. Because it was in the inception idea of, hey, what if we actually changed the paradigm around network and data security? Why should the fundamental challenge? There's 2 problems, right? If you think about how internet protocols evolved over time, right? They had a vision of saying, look, the internet is supposed and focused on plumbing, and all of the security and encryption goes all the way up at the top, and I'll do some ACLs at the bottom.
Right.
But why is it that way?
Right.
Nobody challenged it for decades, and Larry was like, hey, why should it be that way? And we partnered with Applied Invention, and we basically said, what if we actually do security at the network layer while allowing applications to evolve, but the network still understands the fact that you told it to not allow communications to happen a certain way. So the simplest example, and people, I want to give them an example, right? Imagine you have a computer, and you said, I only want to talk on this, in this language, which is say port 80, right? That's what you did on day one. You allowed more application changes happen, things were evolving, and then over time, a network engineer went and said, I want to open up another port. But now your computer and everything that you did is open on the internet.
Yes.
Right? But with Zipper, what you can say at the start is saying, look, go do open port 80 or whatever, but you tell our compiler and our policy engine, our network controller, that computer can never talk to the other network in my on-prem. That computer should never be able to talk to the internet. You can do any changes inside. The intent that you described as part of the policy is buried deep inside our network. And it knows that you cannot allow it to talk. So even if someone opened a port, it'll start traversing and be like, well, I'm going to this other part of the network. Sorry, it was told to me that I'm not supposed to allow it. So even if you open a port or any changes in your network, the cloud protects you with the Zipper technology. Right?
Just to probe further a little bit on that, again, for anybody maybe who missed Larry's keynote or hasn't really heard much about this, why now? Why are we challenging this right now? Like you said, this has been this way for decades. Why was Larry like, let's do this now?
So partially, I think it comes from us innovating further on our off-box network virtualization on our network controller technology, right? So if you go back to when we launched bare metal, we separated what is a physical computer away with our software running outside. We had that. And we've been doing tons of work in that area to like make it even better. And then we said, look, we've got this smart network controller that's sitting outside in every box in our cloud.
Yeah.
What could we make better? And if we were to like go one level up on security, what would that idea be? Mm-hmm. And so it started from taking advantage of our network controller, our off-box computer, and saying, how do we go to the next level? And partially that also comes from the fact that we're seeing tons of new types of attacks outside.
Right, yeah.
Right? And so, and as that continuously rises outside, you go, we've got to change the game.
Yes.
Like whatever we do today, if it was sufficient, we wouldn't be seeing this.
That's right.
And that's where we got to double down even more. How do we take it to the next level? That's what we're doing.
Right. Well, speaking of taking it to the next level, I mean, there's been some, again, amazing innovations that we've been talking about all week. But what is next for OCI? What can our viewers, customers, partners expect over the next, let's call it, a year or so?
Look, I think there's going to be innovation all around, but the one thing that I'm most excited about is that we have 162 data centers and counting.
Yeah.
And I think Larry's vision of having every enterprise, every customer, every school, every hospital having a data center, we're on the way.
Yeah.
Right?
Wow.
That's what I think the customer should expect from OCI.
Wow.
That's awesome. Thank you, as always, for joining us here on Oracle TV, Mahesh.
Thank you so much. It was a pleasure.
Thank you.
Thank you.